All right, in today's lesson here, we're going to try to find the exact value of the following expression. This time we're looking at the cos of 1 degree plus the cos of 2 degrees plus the cos of 3 degrees all the way down to the cos of 359 degrees. So obviously we can't just evaluate all of these here. We don't know these values and there's going to be 359 of them. So what we're going to look at first is we want to take a look at the following results from our correlated acute angles. And using our correlated acute angles, we know the cos of 360 degrees minus theta is equal to the cos of theta. Applying that to these numbers, we have the following. And you can see here I picked a couple of values here. I let theta equal 359 degrees, in which case we make the observation the cos of 1 degree is equal to the cos of 360 minus 359. But again, using our result here that we have, this is equal to the cos of 359. So I know in this case here, the cos of 1 degree and the cos of 359 degrees are equal. Likewise, we have the condition the cos of 2 degrees is going to equal the cos of 358 degrees using the same formula. So again, we have equality between these ones. And this pattern will continue where the cos of 3 degrees is equal to the cos of 357 degrees, all the way up until we hit the cos of 179 is going to equal the cos of 181. And right in between that, we have our cos of 180 degrees, which we know is equal to -1. So we can reduce this list here. I can get rid of the cos of 359 and change this to 2 cos of 1, get rid of the cos of 358 and change this to 2 cos 2, etc. Doing so, we get the following. And now reducing that list here, we now have this is equal to 2 times the cos of 1 degree down to 179 degrees. And then we have our 180 degrees, cos of 180 right here. Now we make the next observation. The next observation is as follows. And we also have the observation the cos of 180 minus theta is equal to negative cos theta. Again, applying this for some of our measures here, let's see what we get. So letting theta be 1 degree and theta be 2 degrees, we get the cos of 179 is equal to negative cos of 1, and the cos of 178 is equal to negative cos of 2 degrees. So what ends up happening here is these end up canceling each other off. So the cos of 1 degree and cos of 179 will cancel each other off. The cos of 2 degrees and cos of 178, which you can't see, will also cancel each other off. So these all cancel each other off here. This entire expression ends up being 0. And we are just left with -1. So just to summarize this result here, when you go to calculate the cos of 1 degree all the way down to the cos of 359 degrees, using our property we had here, cos of 360 minus theta is cos theta, we ended up getting that equality was happening between the 1 degree and the 359 degrees, the 2 degrees and the 358 degrees, etc., all the way down until we got the cos of 179 and 181 being equal. So that ended up creating this formula here. We just ended up doubling each of these values because they were equal. And then we were left over with just this cos of 180, which is equal to -1. Then using our second correlated acute angle, we knew that these two are actually equal to one another just by a minus sign off. So what ends up happening is the sum of these ends up being 0. And likewise, the cos of 2 and the cos of 178 was going to equal to 0 all the way down, which pretty much eliminated this entire expression, only leaving us with our -1 from before. So the answer to this question is -1. All right, that concludes today's example. Take a look here. I have another question, should be linked at the end of this video, taking a look at another expression of the same nature, just practicing your correlated acute angles. Give that a shot as well. Thank you.